Hello everyone, my name is Seunghyun Kim, a CS PhD student at Georgia Institute of Technology. I am advised by Professor Munmun Choudhury. Today I am pleased to present our work, a human-centered systematic literature review of cyberbullying algorithms. Bullying, a pattern of repeated and deliberate harm towards others, has been a pervasive problem in our society for decades. With the spread of digital social technologies among teens and young adults, bullying has now moved into the digital world. Cyberbullying inflicts unforgettable pain on the victims, with close to 2/3 of US adolescents already having experienced some form of cyberbullying ranging from offensive name-calling up to spreading of false rumors. To address the prevalence of cyberbullying and mitigate the damage caused by these unfortunate events, there has been a growing body of research seeking to develop automated systems to detect cyberbullying incidents. There have been a few systematic literature reviews that sought to understand the performance and effectiveness of these cyberbullying detection systems from a technical perspective. Considering the sensitivity around the cyberbullying experience, effects on victims and bystanders, and impact on the online communities, we posit that cyberbullying detection systems need to adapt a human-centered perspective. To that end, we present a systematic review of the past 10 years of cyberbullying detection research. Adopting the three-pronged human-centered algorithm design lens, we examine how the humans were involved and considered directly or indirectly in the building of these detection algorithms, starting from their design and conceptualization to their evaluation and potential deployment. To establish a comprehensive corpus of related literature on cyberbullying detection algorithms, we first went through major academic digital libraries. Combinations of the keywords cyberbullying, detection, detect, and algorithm were used to identify relevant documents. Once an initial search was completed, we coded each paper for relevancy to our scope based on the abstract, methodology, and discussion sections. We then adopted a snowball sampling approach and went through the reference list to conduct a second search. We repeated the process of relevancy coding and going through the references until we reached a stage of saturation where there were no more new publications being added to the corpus. By looking at the reference of the relevant documents at each iteration, we expanded the document base that explores the same domain but possibly published in varied venues. As our iterative approach continued, each iteration resulted in fewer and fewer new relevant documents and more cross-references within the already explored publications, establishing a closed economy of pertinent papers that studied computational methods for cyberbullying detection. In the end, 56 papers remained following the application of our inclusion and exclusion criteria. Once the saturated corpus of 56 papers was established, we adopted Baumer's three-dimensional conceptual framework on human-centered algorithmic design for qualitatively coding the papers. To align the three dimensions, theoretical, participatory, and speculative design that capture the human-centeredness of algorithms to a pertinent coding rubric for unpacking the literature on cyberbullying detection, we followed the following approach. We generated questions for each dimension in a deductive way and at the same time used an inductive approach for verification of the validity of the questions. The induction process first selected a random sample of 5 papers from the corpus to draft a question that would address a shared topic or concept in the subset. Once the question was drafted, another random sample of 5 papers was examined to see if the established questions were indeed closely related to the papers. Then, in the deductive step, we placed the question to the most relevant dimension using their respective definitions. The theoretical background behind the question, what defines cyberbullying, has been largely built upon the work of Dan Olius, which states that cyberbullying is a type of aggression with repetitive occurrence and clear imbalance between the victim and the aggressor. While many studies built upon this theory, there were several studies that used alternative definitions such as the concept of different roles in the cyberbullying incident, such as the bully and the spammer. Most studies were focused on the pragmatism of the dataset curation, relying on the social media platform's API to collect their data. The reliance on pragmatism has unfortunately left out the considerations of theories that could further improve the curation process. There has been a large focus on the vocabulary that is used in the posts when it comes to feature selection. Prior literature fell short of harnessing or unpacking the context of the specific cyberbullying incident, despite that contextual varying data is important for cyberbullying detection, as the content alone does not provide enough information for the classifiers. The models selected for the studies were heavily influenced by the characteristics of the task and therefore were mainly classification models. We noted that cyberbullying theories could be used to shape the problem statement and therefore further provide a theoretical framework on which the models could be selected. Although there has been human involvement in the annotation process of studies, there still remains the question of how researchers can control for the different perceptions of cyberbullying of different people. For instance, the authors of the posts being labeled, the targeted victims, the bystander social media users, community members or moderators, or the platform managers, given the subjectivity of the experience and the diversity of humans who are involved in or impacted by cyberbullying. Importantly, the annotation guidelines in most papers do not thoroughly account for how the life experiences of the annotators could influence what and how they annotate. That said, the inclusion and reliance on feedback from experts seem to be one way to approach a solution to this issue. The absence of the unpacking of these varied perspectives of different stakeholders and the lack of involvement of people with lived experience of cyberbullying indicated a shortcoming, since it would only provide one subset of the possible perspectives. The majority of model evaluation approaches were based on the statistical measurements such as precision, recall, and accuracy. While these metrics measured the technical performance of the models, there was a lack of detailed interpretation of the performance metrics based on direct human feedback, whether experts or other stakeholders involved in cyberbullying, information that could provide a deeper look at the misclassifications. While prior research has shown varied approaches to define the particular research goals, the majority did not speculate how the developed models would be utilized in real-life scenarios. That said, it is often the case that application to real-life scenarios would become an industrial problem and may not necessarily be an expectation for research that develops the detection models. Consequently, considerations of real-life applications are recommended, as researchers are likely to benefit through incorporating speculative design to understand how different stakeholders could benefit from their models. There were acknowledgments about the interpretation of the implications of the developed classifiers, which related to their speculated use in the future. Some papers argued that detecting cyberbullying alone has little practical value unless the participants involved in the cyberbullying incidents are also identified. There were studies that noted the reliance on external annotators, speculating that the real-world use of these classifiers might be limited as the annotators' perspectives might not generalize. Implications of misclassifications were also mentioned in papers as a significant challenge toward practical use. That said, we were not able to find any studies that specifically discussed any potential negative consequences that could arise from implementing these models to social media platforms. On that note, our work suggests future research on cyberbullying detection to incorporate human-centeredness. In order to account for differences in transferring the definition of bullying to specific and unique online contexts, researchers would need to identify and understand the affordances of social media platforms. There is a need to establish a set of theoretically grounded features that could be benchmarked across datasets, cyberbullying types, and definitions. Strengthening the theoretical background behind feature selection could also control for potential overfitting from including irrelevant predictors. We argue that developing theoretically grounded foundations for feature engineering and model selection could be meaningful not only to examine why a certain feature or model should be considered, but also to support cross-comparison across studies. Cultural differences should be accounted for when considering the perceptions of harassment and aggression among victims as well as bystanders. In addition, involvement of the victims of cyberbullying as well as other participating stakeholders such as bystanders is very important to address the construct validity issues of annotations. Computational measurements of model performance could be strengthened with human evaluations, identifying the extent to which the algorithm is successful in achieving what it set out to do. As there is a symbiotic relationship between what an algorithm does and the world it exists in, future researchers could speculate the usage of the models to understand how the stakeholders could benefit from the classifiers and also consider potential negative consequences of cyberbullying detection systems. In this paper, we conducted a systematic review of the past literature on automated cyberbullying detection models. Our review revealed clear gaps within the extensive research on developing cyberbullying detection models that optimize for statistical performance and methodological innovation. We concluded with guidelines on how a human-centered approach can help to address these pervasive concerns in this important research area within social computing. And that concludes our presentation for our paper. Thank you very much.